a kind reminder to mute yourself. We're gonna open space for questions, or I'll let the presenter decide that. But try to mute yourself so you don't interrupt the rest of the meeting. Um, Thank you for being here. This will be recorded and it will be placed in the Pacific Hackers YouTube page. As we all know, and we always begin the meetings with a little bit of an FYSA. I'm not sure. I hope all of you guys are doing well and are staying safe. Um, Based on what we've been gauging, I guess, in the situation, it hasn't been really um, big layoff now. If you were laid off, request access to your Slack. There's tons, I repeat, tons of remote work. There's lots of work. So if you work in InfoSec and you were laid off, we could probably help you. Again, join our Slack. If you send me an email to info@bhack.org, I will add you to our Slack channel, which is the percent-27slack.com. And we have multiple channels there. One of them is the current disaster, where there's a lot of chatter about what's going on. And we have job postings for everybody, training. We have multiple resources that can be used for your advantage. So uh, yeah, recapping a little bit, unfortunately, we had to cancel the Bay Area CTF, which was going to happen in Santa Cruz. Santa Cruz is, I read it was reopening their beaches, and it looks like there's hope that we will start reopening soon. We will continue doing these meetings online until we think it's safe to go back. And I will communicate with the library or Marco, and we'll make a decision. We want to be careful not to rush it back, and not to make a mistake. Looking back, for at least some of you, we went to RSA and then we saw people getting it from RSA. So we want to be careful once we start the process of coming back. Hopefully, this will happen. I think somewhere between maybe June, July, or even earlier. But as of now, that's how it looks like. Um, Other than that, Marco, you want to say something?
Yeah, just a reminder for everyone to mute yourselves, and also for Paul, do you want? I'll keep monitoring the chat for questions. Do you want people to ask the questions directly, or do you want me to one reading the questions?
I'm sorry, the options were ask the questions directly, or you're going to.
Yeah, so the people can ask interrupt you and ask the questions directly, or do you want to hold the questions for at the end? How do you want to do it?
Well, we could try interrupting if it turns out to be a lot. Maybe we can just start holding at that point for the end, because I'm going to demo a fair number of things, so there might be a fair number of questions. But yeah, we could try with the interruptions.
Okay, cool. All right.
Well, everybody, this is Paul, and he is with PolySwarm. And we have their team here today, so we'd like to welcome them and thank them for helping us, obviously, do these meetings. So I'm going to let him take over, and we'll go over with questions, and we'll take it from here. Thank you.
Cool. Thanks everyone for joining today, and thanks Rod and Marco for hosting this. Can everyone see my screen? I guess just one person needs to respond. I have a slide up. Cool, great. So thanks for inviting me. So today we're going to talk about hunting and pivoting using research-driven threat intelligence on the PolySwarm platform. So if you've never heard of PolySwarm, but you've heard of VirusTotal, you already have a pretty good idea of what PolySwarm's about. VirusTotal, obviously, you can upload files, you can scan, search for hashes, you can do some searches as well. And we're going to show you how to use some of those features on PolySwarm today, and hunt for new and emergent threats, and find samples that you're not able to find elsewhere. And critically, as part of this, and one of the reasons why I'm really excited to present this to everybody here is we have free accounts, and those free accounts allow you to do everything that I'm going to demo today, with one exception, and I will note that when I get to it. But yeah, so it's great to speak with you all. Unfortunately, I haven't been able to meet with you in person, but maybe June or July timeframe, I can meet you all in person. So a little bit about my background before we get started. You may have seen the meeting link. I got my starts kind of in vulnerability analysis area, reverse engineering. I worked for the Department of Defense for a few years. Left and then worked for a contractor that primarily did work for the U.S. government and Fortune 100 sort of companies. And then myself and other members of this contractor called NARF Industries created Polyswarm, co-founded Polyswarm, as a way to bridge the economic gap between everyone that's doing really cool stuff in the malware detection space as individuals and small information security companies, and the large kind of anti-malware, antivirus enterprises, right? So what we wanted to do is we built Polyswarm to enable market access for tools that would otherwise be published in Usenix or some academic venue and go sit on a shelf on GitHub forever and not actually help anybody. So we wanted to provide a way for people to make money and also improve their skills and test out their malware detection ideas on real enterprise traffic. All right, so here we go. So I have a little agenda here. First, I'm gonna, I kind of went through the intro a little bit. I'm gonna tell you about PolyX in a moment here. Then we'll speak a little bit about how Polyswarm works. And then we'll get into the meat of the conversation, which is we're going to take a look at some recent headlines, some blog posts by the likes of Trend Micro and Lookout and ZDNet, and take a look at some malware that they published about, find that malware on Polyswarm, and then pivot using attributes of that malware to find additional malware that wasn't even published in those articles. Right? So again, anybody that is listening today, or anybody anywhere can create a free account and do everything that I'm doing today, and you would very quickly have something to publish in and of yourself, beyond what these headlines are showing. After that, I'm going to dive a little bit deeper into what we call metadata searching. The way that this works is when a file is uploaded to Polyswarm, we run a lot of different static analyzers on that file. And which analyzers are run are dependent on the type of file. But in the case of, for example, Windows PEs, we'll extract things like what DLLs does it import, what functions does it export, and all of those attributes about a particular file become searchable in an Elasticsearch cluster that we have. So very, very rapid, and you can form really complex queries, the likes of which are show me all of the Windows executables that you've gotten from the last week that were detected as malicious that export this regular expression of functions, for example. So it's quite flexible, and I'll dive into that a little bit as well. And then we'll wrap up and do some Q&A. But before we do any of that, I want to alert everybody here to this community that we have called PolyX. So we have this, it's a Slack group, and it's a little bit more, where if you join PolyX, and all you have to do is go to polyswarm.io/PolyX, tell us who you are, and you get a free upgraded account on Polyswarm. So the free accounts, even without the upgrade, can do everything I'm going to show today, but with the upgrade, you get double the number of free downloads. So if you're interested in finding malware, reverse engineering it, and improving your skills in that area, we'd love to have you as part of the community. What we get out of it is potentially some people are interested in taking their malware detection ideas and building an engine out of them, right? So Polyswarm, unlike VirusTotal, makes it really easy for people to plug in their own engines into the marketplace. And by doing so, you get access to all the samples that are being submitted. So we have documentation, we have, Docker files. We try to make it as simple as possible to get started. And if anybody has any interest in potentially detecting some malware via some new idea, it would be great to hear from you, and it would be great to support you in that. We have some big names in this community as well. We have the head of anti-malware from Google Play. We have the head of innovation at SentinelOne. We have a bunch of people from Kaspersky, Avast, ESET, Ernst & Young, and probably if you're in the track of malware space, you're probably following a lot of the people on Twitter that are in this community. So we have about 400 members right now, and it's growing pretty rapidly. So it'd be great to have everybody here as well. So before I kind of show you some of how Polyswarm works, I want to talk a little bit about the hosts. I believe I noticed the chat up in the top right. I think you can mute everybody if you want to do that. Aside from me, hopefully you don't want to mute me. But so how Polyswarm works. So there are a few things different from what we're doing compared to what the likes of VirusTotal or OpsWad or Reversing Labs are doing. And one of the core pieces is we actually incentivize engines to, can anybody else see these slides? Anybody having trouble seeing these slides?
I can see the slides.
Okay. Somebody mentioned they couldn't, so. All right, so yeah, so a big differentiator is we actually financially compensate engines for low false positive and false negative rate. So engines that perform better in the sense that they accurately detect whether or not a file is malicious or benign stand to gain more profit than engines that maybe fell behind on a particular file, right? So what we're trying to encourage with this is, particularly by reaching out to small engine providers, small companies, and even individuals interested in engines, is they'll bring something unique to the table. We have people that, for example, we have an engine, and I'm going to highlight a few here. But they only take a look at PDFs and Microsoft Office documents, and then they try to detect malintent inside JavaScript and macros, respectively in those documents. But that's all they take a look at, right? They're not interested in becoming a generic sort of antivirus product. They have their niche, they have what they're interested in, and they do a really good job at tackling that. So that's one big difference. We do have large antivirus companies on board, but we also have smaller individual security experts bringing something unique on the fringe of what traditionally is detected by anti-malware products. So continuing on here. Another big difference is we create statistical models in terms of how engines have performed in the past against similar files. So if you upload something to VirusTotal today, you might get 60 to 70 different responses from engines. Let's say 15 of them said malicious and the rest said benign. Okay, what do you do with that information? You now need to make a decision based on it. So Polyswarm helps make that decision for you. We track how engines have performed against various different verticals in terms of file type, or in terms of, but that's file type is what we're doing right now, but in the future, things like, malware family and things like that. So we maintain this model, and when you get results, not only do you get results from what the engine said, but you get what we call a polyscore, which is distillation of all the engine results into a single value between 0 and 1. Where 0 is benign and 1 is totally malicious. So I'll show that a little later too. Okay, any questions on that so far? Otherwise, I'm going to jump into the meat of this right now. Okay, I see a question, and that's a question we get often. How do you establish ground truth in terms of who got it right? It's a great question. So what I've spoken about so far is engines on the platform, and engines anybody can write, anybody can plug in. We also have a class of participants on the marketplace called arbiters, and arbiters are already established companies. We have some large names already on the platform that we haven't announced yet that are helping us with arbitrship. But what we're doing is, well, so what we observed in the marketplace or in the industry in general is it takes about 2 weeks before the entire antivirus industry to agree that a particular file or set of files, malware family, is malicious. You know, somebody might detect it first, publish a blog post, get that marketing bump. But it might take on the order of about 2 weeks before the industry as a whole is detecting it. So what we do is, while engines need to respond on the order of seconds to scan files, because people need to make decisions based on what to do with these files, arbiters actually have 2 weeks to return a verdict. And what that allows for is that allows one, deeper analyses. One of the arbiters on Polyswarm is developed by the lead developers behind Cuckoo Sandbox, for example. They spun up their own company called Hatching. They have a product called Triage that's kind of an evolution of Cuckoo Sandbox. And they're using that on our back end as one of the arbiters. So they can actually detonate files and go through full execution, whereas engines need to do something that fits within, you know, a several second time window. So we're partnering with, you know, well-established people in the space and giving them a bunch of time to come up with a better answer. I'll admit, you know, that's not perfect, but that's what we have right now. Where we're going from here is we're going to dynamically select arbiters based on the particular file in question. So, for example, Caleb Fenton, the head of innovation at Sentinel-1, in his free time is writing an Android banking Trojan detecting Polyswarm engine, right? And he's really good at detecting Android banking Trojans, no surprise. So, you know, if he continues to perform, if his engine continues to perform really well, in the future, if an Android application comes through, perhaps his engine is chosen dynamically as the arbiter for that engine. And I got another, okay, cool, answered it. Got another question. How do you apply to become an engine? I can go over that a little bit later. You actually don't need to apply. Anybody can build an engine. I encourage you to check out docs.polyswarm.io. That's where you can get started under the suppliers tab. But yeah, we're happy to have anybody and everybody on board. And you get access to files and you can test out your ideas against real enterprise files. So big difference there relative to other threat hunting platforms. Okay, so let me get out of this. All right. Okay, so now we're going to go hunting. All right, so I have a few little stories here, or rather, before I do that, let me just show you real quick. So you may have seen polyswarm.io. Polyswarm.io is really just our marketing site. The meat of what we're doing is on, in the application itself is on polyswarm.network. So anybody can go here right now, and it looks like the bottom of my screen is being cut off for some reason. Let me do this. That's looking better. Let me try this one more time. Okay, better. So on polyswarm.network, you'll see on the front page, we have this new feature that we call merging threats under the Discover header, where you can see some examples of EventBot that's recently in the news, some COVID-19 related samples. These are things that are being pushed to people in terms with phishing emails and web pages that mention, you know, coronavirus, trying to get people to install these things. We note when we had it before other vendors, so that's, you know, interesting. Zoom-related malware, and we're going to be hunting a lot of these, so I'm going to come back to this later. TrickBot and Emotet. This interface right here, you can drag and drop a file, you can search a hash. And I'm just going to blow through this real quick because we're going to go through specific examples in a little bit. And again, and particularly for anybody who joined late, all of this is free. So we'd love to have you on board searching things. Everything I'm going to show here, with the one exception of Yara-based hunting, is free. So going over here, we can search for hashes. We're going to do a lot of metadata searching here, and I'll show you hunting later. And you can see the current engines on the platform over here. So I wanted to highlight, I kind of highlighted a few already, but to highlight another few engines that kind of provide some unique insight here, we have something called Consinity Risks, which is actually a company that sells risk metrics to cyber insurance companies. And part of where they derive their intelligence is they track cryptocurrency addresses used for ransomware payments, for example. So they actually have a large graph database of various blockchains, and they can see when funds move into, and they have some heuristics for what appears to be a malicious address, or where the gains from ransomware are going. And so they have an engine on Polyswarm, and what that engine does is when a file comes through, they check that file for any of their known bad, ransomware sort of cryptocurrency addresses. And if it appears in the file, that's a pretty good indication that that file is malicious, specifically ransomware. So that's kind of a unique aspect. And then I mentioned before, although I didn't name it, IrisH is the one that takes a look at PDFs and Microsoft Office files. They actually detected some previously unknown malware inside of a Microsoft Excel file 4 days before anybody else on Polyswarm did. And then it took another 3 days before that file appeared on VirusTotal. So there was about a week lead time. And then I mentioned Caleb Fenton is building an engine called Android Judge that looks for Android banking charges. Okay, so let's dive into. Let's go to this blog here real quick. All right. So just a few days ago, just a few days ago, 3 days ago, Lookout published this blog post about nation-state mobile malware targeting Syrians with COVID-19 lures. So they attributed this campaign to the Syrian Electronic Army. This campaign seems to be active since the start of January 2018. So only recently did they start adapting COVID-19 lures to spread this malware, but this malware family has been around since that long. None of the apps were in Google Play Store, so they're probably installed by third-party app stores or directly. And a large portion of the malicious applications are spy note samples. So let's scroll through here a little bit. We're kind of picking out some of the key details in this blog post. And the malware actually drops a fake app that allegedly takes your temperature through your phone screen when you put your finger on your phone. I don't know, I guess that tricks some people. So yeah, so if we scroll down to the bottom, so this is a great example of, an anti-malware company publishing a blog post, getting that marketing bump and, sharing with the world what they found, helping other people detect these malicious apps. And if we scroll down to the bottom, here's the fingerprint read your temperature app. 35 degrees Celsius, it's probably pretty hot. Scrolling down here, okay, so at the bottom, they list a bunch of SHA-1 hashes of applications that they observed that are part of this campaign, right? So let's take the very first hash in this list and let's go to Polyswarm. And let's search it. Hooray, we have it. So, and a lot of the engines identified it as spy note. I'm going to show you what this looks like both via the web interface and the CLI. I mentioned earlier about Polyscore. That's not currently on the web UI, although it will be soon. But you're going to, let me just show you real quick. If you search the same thing on the CLI, you'd be able to see the polyscore. Let me increase my font size so everybody can see that. Okay, it's a polyscore of 0.99999. So we're quite sure it's malicious. And I'll show some more command line stuff later. But what we can do here is we search the SHA-1. We found it. We can download the file now. Again, even free accounts can download files. And if you join PolyX, you get double the number of downloads for free. But another thing I want to show is this file details tab. So this is what engines thought about the file. But as I mentioned before, we have a lot of different static analyzers that run on files as they're ingested. So we look for things like strings that look like domains or strings that look like URLs. And then we also hash it for not just the cryptographic hashes, but also fuzzy hashes like SSD and TLSH. Now, this is actually, because this is an Android application, it's actually detected as a zip archive because APKs are zips. So we're not looking so much into the zip yet. I'll show you a Windows executable where this is just pages of results later on. But I wanted to show you some of these URL-like things that were extracted. So if we go back to this blog post, one of the things I mentioned, it's in res values. Okay, one of the things I mentioned, not all applications in this campaign were completely scrubbed of sensitive information when they were created. A large portion of the malicious applications are spy note samples, which store C2 information, along with user inputted names, version numbers, and other information in res values strings. Okay, cool. So we just searched the first SHA-1 on that, and we have it. So let's download it. Okay, I've downloaded it. I'm just going to call this spy note. Copy this from my downloads folder. Let's make it end in APK because APK tool likes that more. Okay, so let's pull this apart using APK tool. Semblance of the original source code and directory structure before packaging an Android application. So it produced a folder named after the name of the APK. So let's take a look at res values strings, just like they said in the blog. And we don't really know what each of these keys mean necessarily. mtbin is a embedded jar. They mentioned this in the blog post as well, within the application that's obfuscated a little bit more. But we can see in clear text what the values are that go along with these keys. So if you take a look right here, that looks like an IP address. This offset within mtbin is probably the C2 address argument. So we have this IP address here, 82.137.218.185. They did not publish this as part of the blog post. Lookup didn't publish this IP address. So let's copy this. Now we're going to ask Polyswarm to find. One second. Well, before we do that, let's check our assumptions here real quick. Oops. Okay. Who is this IP address? Syrian Telecommunication EST, located in Of these results, I did the homework before this presentation. 23 of them were not included in Lookout's IOC list. So if you were to do this exact same thing, you would already have something to tweet about, something to show the world. This is also a malicious Android application, same C2 address. So 23 of them were not in the Lookout IOC list, and 5 of those that were not in the Lookout IOC list also are not on VirusTotal. So that's pretty great. And as part of this, let me just pull up another one. Again, you can kind of take a look at the file details here. And under the file details, oh, here's IPv4-like strings. Thankfully, even though it's inside of a zip, I guess IPv4 type strings don't compress very well with the deflate algorithm. So this strings utility, it's literally us running strings. We're incorporating additional static analyzers like Flare's Floss for deobfuscating. So for deobfuscating strings inside of files. And again, thankfully, we didn't have to actually peer inside the zip. That's just appeared via strings. So if it had not appeared just by running strings, there's probably a lot more examples on here that we're just not finding by searching for string output that matches this IP address. Cool. So any questions on this particular example? I think I can chat. All right, cool. I didn't see any, so. Moving on here. So Syria didn't want to be alone in their COVID-19 related malware, Android malware. So let's take a look at this article. It's on ZDNet. So Iran published an official COVID-19 detection app called AC19, and it was in the Google Play Store for a bit. Google removed it, and people believe because it had some misleading description about it in terms of it can detect COVID-19, which it can't. Apps can't. But it also tracks whoever installs it in real time. And this app it's still available if you want to take a look at it. The latest version is at ac19.ir. So although it's not on the Google Play Store anymore, a lot of antivirus engines, anti-malware engines are identifying this as malicious because it is something that is deceptive in the sense of how they described it. And persistently always collects location data and sends it back to the Iranian government. So if we go down to the bottom again, you typically find IOCs at the bottom of these sort of posts. Oh, and here's something worth mentioning. The Iran's Minister of Information and Communications Technology tweeted that they have already collected location points from more than 4 million Iranians with the help of the app. So quite a rich data set here. But if we take a look at the bottom, they actually link to VirusTotal here. We're not going to do anything on VirusTotal aside from just take this SHA hash out of that link. And then let's run the same thing against Polyswarm. This is SHA-256. And we have it. Cool. So now what we want to do is, okay, so this ZDNet article published a single hash of this malware or spyware, and we want to find other copies of it. Maybe we want to see how this malware or spyware has evolved over time, for example, what new features were added, what was removed, things like that. So why don't we take a look at the file details. And one thing I want to emphasize here is everything that is in the file details tab and more, because you actually see more by the command line, is what we call pivotable. So, the topic of this conversation that we're having today is hunting and pivoting using research-driven threat intelligence. So anything that you see on this page, you can formulate a metadata query for and do Boolean logic in terms of having ands and ors and nots in between these conditions to find additional samples. So here's a domain-like string that looks pretty interesting, I would say. So there's COVID-19 e9057.appspot.com, and they actually have the same thing .firebase.io, which tells me they're using Google Cloud Platform to host the backend for their app, right? So E9057 is a unique identifier, and their project name is probably COVID-19. So they're reporting back to HubSpot and Firebase.io. Somebody unmute. Okay, cool. Okay. So if we take a look at this, let's do. Okay, so here's one potentially interesting domain. Let me see if there's. Yeah, there's a lot of strings in here. Let's formulate a metadata query for strings dot. Let's actually go with URLs. This. And we don't really care if it starts with HTTP or HTTPS. We want to find anything here. So what we're going to search for here is give me all the files that have URL looking strings in them that start with anything and end in this. Let's hit enter. All right, we have 4 results. So one of them we already saw, but the other ones we didn't. And the other 3 were not published as part of this blog post. We can, again, you can download these files, you can reverse engineer them, you can take a look at what might have changed perhaps over time. Maybe one was built earlier, one was built later. If you go to the file details, you can see that, yes, it has the same sort of domain-like, URL-like strings in them. And you could publish some interesting research on that in terms of, you know, what kind of features are they adding or removing to this application? What bugs are they fixing? Okay. Any questions on that? I have another fun news story to go through next. Okay, so we've been doing a bunch of Android-specific things. Let's switch gears a little bit and go for some Windows-based threats. So in addition to COVID-19, a lot of malware authors have been using this hubbub around Zoom. Everyone seems to be flocking to Zoom, saying things about Zoom. So malware authors are trying to inject themselves into the conversation, bundle their malware as part of installers that look like they're installing Zoom, or maybe they actually do install Zoom, but they install a few other things as well. So Trend Micro published this blog post about a fake Zoom Windows desktop installer that also drops a coin miner. So for those not familiar, coin miners are, you're just mining cryptocurrency. But in this case, you're not mining cryptocurrency for yourself. You're mining cryptocurrency for whoever owned you. So this fake installer will drop a coin miner, will drop the Tor binary, and we'll drop a few other things, and we'll see what they are in a second here. But we'll connect to the Tor network and start mining coins on behalf of the attackers. So that's how the attackers are making money. Okay, so let's kind of scroll down here. They're talking about some of the things that are part of this fake installer. And for those familiar with this sort of script, it kind of looks like PowerShell, right? So let's scroll down here. They list some of the names of the things that are dropped along with it. It's a good blog post. You know, they go through what's unpacked. They have they actually bundle the 7-zip extractor along with their installer, and then extract something that is 7-zip compressed within it, one of the DLLs. Here's another snippet of the PowerShell that they're using. Let's scroll down, and it does some things like detecting whether or not you're running some antivirus solutions. And if you are, just don't do anything bad. Kind of interesting. Some situational awareness there. Okay, continuing to scroll, typically IOCs are found at the end of these blog posts. Oh, and it maintains persistence. So it creates a scheduled task that will kick off the mining process each time the computer boots. And it also actually checks to see whether or not the computer has access to GPUs. And if it doesn't do anything malicious. If you're mining coins nowadays and you're doing it on a CPU, you're going to have a bad time. So it's not really worth it. And people might notice if your CPU is running hot all the time. Anyway. Okay, scrolling down. Okay. So we have a few SHA-256s here of the installer, of the payload, and also of some URLs, indicators of compromise. So we're going to take a look at, let's take a look at this one. All right, let's go to Polyswarm. So this is similar to what we did before. Searching metadata. We have something that looks like a URL. Of course, it's not HXXPS, it's HTTPS. And we're going to deobfuscate this. And let's search that. Oops, did that wrong. It's because I have the colons in here. Okay. So we found a sample here. Let's pull this up. Now, interestingly, this sample EF starts with EF, the SHA-256 starts with EF and ends in CE. If we go back over here, that's not one that's mentioned on the Trend Micro report. So we have a different one. So why don't we, let's make sure that this is actually what Trend Micro is talking about. So let's download this. Let's do, I think I already have a Zoom folder. I already downloaded it, moved it here, and renamed it to .ps1 because it's a PowerShell script. Let me open up VS Code. Well, let me just do it in. Just do it in Vim. So this is the script that kicks off. There's a few things that they mention in the blog post that are kind of telling that this is the same thing that they're talking about. One of them, of course, is the callback address. Let's search for that. Oops. Okay, $SURL equals exactly what it is that Trend Micro published. Probably the same thing. Now, Trend Micro mentioned that they also bundled the 7-zip extractor and Tor in here. So I scrolled through here so you didn't have to. This is ugly, but you can include binaries inside of PowerShell scripts by just having a bunch of hex values and handing them together. So they have 7-zip bin equals this massive array banded together of hex values. And that'll be dumped. Oops, let me go back there. There we go. That'll be dumped to disk and then used to extract other things, including, say, for example, Tor bin. And then we'll call Tor bin. There's Tor bin. So Tor bin is, if I recall correctly, 7-zip compressed as well. So it will dump the 7-zip binary to disk, the unarchiver, and unarchive Tor, use the Tor binary to connect to Tor, unarchive their coin miner, run that, start an auto execution thing so that it runs on each boot, and they're on their way. So yeah, this definitely looks like the same thing that Trend Micro is talking about. Again, you can play along at home. A lot of other kind of outlets don't let you download files like that. So that's one thing that I wanted to show you. Any questions on that that article and what we can do with that? Okay, so one question was that we just got is for the static analyzers, does it include things like imp hash, if I saw it correctly, as well as what other kind of things it imports? Let me just show you. Annotate somebody wants to annotate the shared content. Imp fuzzy hash. Okay. I don't know about imp fuzzy hash. If we don't have it, I'd be happy to add it. Imp fuzzy hash. We have imp hash. Let me show you that. So imp hash is, so I'm going to upload a file here right now. This file is puttyx.exe. And what it is the SSH client, Putty, that we injected with Metasploit's interpreter. So it was benign. And so we modified it. And we injected it with interpreter. So let's scroll down here. So we have the normal artifacts under file details. We have the normal hashes. But we also run, because this is a PE file, we run, no surprise here, we run the tool PE file to extract some things about this file. So it'll extract things like, hey, here's all the imported functions from the Windows PE. Here's the DLLs that it imports. Even says things like, does it use ASLR? Things like that. PE file is not the only one. We also run Leaf, which provides admittedly a lot of kind of overlapping information, but there are a few things that Leaf provides, a PE file doesn't, vice versa. And of course, under strings, you can see how it's referencing OpenSSH.com, but we'll see in a second when we switch over to details how a lot of engines identify this as an interpreter. So as part of, if I recall correctly, as part of Leaf's output, they have an imp hash. Let me just scroll down here. Maybe it was PE file. Yeah, import hash. So PE files import hash, what it is it takes the imported libraries, sorts them alphabetically, and then runs a hash function, I don't remember which one, over that list. So you can, often you can find similar samples, perhaps even from the same family, by searching for the import hash. Even if you have like some polymorphic sort of malware, one thing that malware authors may not change when they generate multiple copies that look different on disk is what sort of libraries are importing, right? So that's one example of a fuzzy sort of hash. I'm not sure if it's the same thing as imp fuzzy hash, but it is a fuzzy hash in the sense that it's not a cryptographic hash, and it's meant to identify other samples that at least have the same DLL imports. So that would be something that we could search by metadata searching. So I haven't done this one, but I'll show you how to do this. Let's see, if we wanted to search this imp hash, I'm not actually sure if we have another sample that has this imp hash, but let's find out. pfile.imphash. Oh, well, we do. We have a lot. Cool. The demo gods are with me today. So that might be, oh, let's just scan one of them. Here's what it is. It might just be a bunch of different, let's scan it now. A bunch of different interpreters. Anyway, let's switch back over to here. And as you can see, Alibaba says, hey, this is an interpreter. Generic sort of backdoor stuff. Rising says, hey, this is an interpreter. Again, let's take a look at the polyscore. The polyscore is probably going to be very high. Oops. Yes. Yes, great question. Do we capture the debug output, or do we capture debug information that is sometimes embedded within Windows executables? We do. And I actually wasn't going to demo that, but now I will. So thank you. Let me show you. So here's another article. This one's from FireEye. They published this article back in August of last year, and what they were showing as part of this article is a lot of malware authors are very sloppy. So when you build malware or when you build an application on Windows in Visual Studio, Visual Studio can generate what are called PDB or program debug files as part of the build of the binary. And this helps with debugging the files before release. But sometimes malware authors forget to strip references to these PDB files included in their malware before they go out to their targets, right? So let's scroll through here. And some of these are pretty funny. So I'm actually really glad you brought this up. Here we go. This guy or girl, could be a girl, in D:/S Miller, maybe it's, I don't know, Steve Miller from the Steve Miller Band, /project/super evil stuff /shellcode. So there was some malware that they caught that has a reference here, you see right here, to super evil stuff. So not great OPSEC. Actually, I think that I might maybe misspeaking there. I think that might just be their example. Yeah, I think that's their example. But the actual mistakes are no less funny. Let's scroll down. There was one in here. Here we go. In Operation Shadowhammer, which uses a myriad of connections to apt41, one sample had a simple yet descriptive PDB path, D:/C++ ASUS shellcode release ASUS shellcode.pdb. Okay, cool. Let's see if we have it. Let's go back to Polyswarm. We're going to do a metadata search now. And we're going to look for, so PE file pulls out information about PDBs that are resident within any references to PDBs, reference within the PE file that you're taking a look at. So let's look for anything that, so this is going to be a PDB path that starts with anything, but ends in shellcode.pdb. We have a lot of them. Not all of them have been scanned, but a lot of them have. Let's just pull up one that has. Chris actually thinks there's an interpreter in it, but you get the sense here. I think that answers the question. If I go back here, go to file details, part of PE file will have a PDB section. Actually, we won't. Okay. Well, this is a good example of, just for the sake of brevity, we don't export and we don't want to crash everyone's web browser. We don't put everything on the web UI. So let me show you how to find PDBs interactively on the command line. So let's do, I'm going to do the same metadata search. I'm going to ask for the output, not in human readable format, but I'm going to do it in, I'm going to do pretty printed JSON. Okay, well, it's returning a bunch of results. So hold on, let me just, let me actually just search this hash so I have the exact one. Of course, it's returning all those results. Formats. JSON. Cool. So let's scroll up. So everything that it just spit out is, what it spit out is more than what's on the web page, right? And this is just outputting in a JSON format. So it's really easy to integrate with whatever processes you currently have. It's all very programmatic. And you don't actually have to use our CLI. We actually have a very full features API as well that supports both Python 2.7, unfortunately, and also Python 3. So you can integrate with that as well. And this is made, I wasn't necessarily going to go into the API stuff today because that's a little deeper dive than just actually doing the hunting. But let's scroll up here. So here we go. This PDB or list actually has within it, and this list is underneath PE file. So the PE file tool returned information about PDBs, and in this particular sample, it had a reference to a PDB file that was day one Tide shellcode tech, CP shellcode release com shellcode.pdb. There you go. So yes, you can get access to PDB files, references to them. It's pulled out a PE file. So if there is some field that you would expect, like say PE file or leaf or something to be exporting, but is not on the web UI, it's probably on the CLI, but we just don't want to crash your browser because it'll be too much data spit at you. And to get a sense for like the different fields you can search in metadata searching, we have some documentation at docs.polyswarm.io. But we also have this other project. We go to consumers here real quick. Command line, form searches. Or rather, let's do the. Here's some metadata terms. Although this is not the complete list, we're working on auto-generating this. There's actually a lot more that you can get out of this. So if you play with Polyswarm after we were chatting today, basically if you search a hash, take a look at what things are spit out as part of that, and you can formulate queries based on any of the fields in there. Okay, well that was a little bit of a diversion, but let's go back to. Okay, so I'm going to get a little bit more in the weeds here on metadata searching for people that want to do a little bit more advanced searches. But before I do that, Emotet's in the news. We have some both automated and manual processes for tagging known malware samples based on both attributes of that sample. Maybe it's ransomware, for example, and family name. Maybe it's RYUK or RYUK, however you pronounce it. So the family could be RYUK and be tagged with ransomware. So if we take a look at Polyswarm tag list, we can see what our current tags are, and we have a lot of them. And this is actually what we use internally for putting things on the front page in terms of emerging threats. So why don't we take a look at Polyswarm, and then we're going to see what samples are linked and list those samples linked with the family Emotet. And it's killing my terminal because there's too many results. So why don't we instead just figure out how many there are. So again, this is a combination of manual and automated processes. And we'll get a certain number of definitely known Emotet samples here, including Emotet samples that were unpacked. You see at the bottom of the terminal right there, the last one that spit out before I Control-C did. That is actually an unpacked Emotet sample. So we have 148, which is fine. That's not a lot. So let me show you. Let's formulate a different metadata query here. What we're going to do here is we're going to search all files in Polyswarm that were identified as by any of the engines as part of a malware family that starts with any string, then contains Emotet, then ends in any string. Right? And what we're going to be asking for is just a list of SHA-256. Let's go to the end here. Let's just redirect that. I'll take a second because we actually have a lot of results. And that warning that showed up, you can just ignore that. That's not a big deal. Okay, any second now. Well, let's see what we have so far. Well, I'll spoil it for you. We have something over 5,000. So I'm going to Control-C this so I don't waste everyone's time. So we have 5,645 results for that query. Last thing I want to show in this kind of section is we actually started labeling. So some engines label samples that exploit various vulnerabilities as having CVE in their family name. So if you want to find exploits, you can do that on Polyswarm. Let's take a look at some samples that were detected as malicious by engines on Polyswarm that had a malware family that contained the string CVE. Those samples almost certainly are exploiting the CVE that they're tagged with. And again, I won't necessarily waste your time here. There's 2,500 of these. So you really, okay, that one was faster. So exploits. Yep. And it looks like a bunch of SHA-256s. So I could cat exploits into Polyswarm download, read from standard in, and let's download to lead exploits. So, I did that wrong. All right, so I'm going to Control-C this because I'm not actually going to download 2,500 files. And we have a bunch of files already downloaded. So this is great for trying to find things that were exploiting various CVEs. And one thing that we actually did special case here is we added detection to PE file for the NSA reported vulnerability in Windows certificate checking. If anybody remembers that, so you could pass, their certificate validation. Anyway, we have 22 samples that exploit that bug as well. Okay. Any questions so far? Anybody else have any questions in terms of, hey, this would be a cool thing to search or something like that? I'm going to show a few other things just to show kind of the strength of it. Take a look at this search. So what we're doing here is we're asking for, hey, give me all the files that were first scanned on April 14th at 0000 hours UTC to April 14th at 00:15 minutes, April 14th, and that 3 engines detected greater than 3 engines detected as malicious, and give me those SHA-256s. Okay, so there's a question, demoing the CLI, something about Docker. I am not in a Docker image right now. You could, of course, do this within a Docker image. I just have a virtual environment, and all you have to do is, if you're running Python 3, pip install -u Polyswarm. That's it. Well, I kind of lied. That's not quite it. You also need an API key. So first step is to go to polyswarm.network. If you haven't created an account, create an account, then go to settings in your account, and that will display your API key. And then what I did is I just sourced my API key from a file that I had. So it's actually just in my environment, so that the Polyswarm command is using my API key. Otherwise, you do something like Polyswarm A, whatever your API key is. Okay, so we got a list of those files that match that criteria. Let's take a look at hash. Cool, it's a bunch of SHA-256 hashes. Now let's do something else kind of complex with that file. So we're going to search hashes by ingesting that hash.txt, pipe that into JQ, so we're parsing the JSON that's coming out. And we're looking at the SHA-256 and pairing it with the polyscore. And we're going to output that to polyscore.txt. So this is really quickly kind of amassing a correspondence between SHA-256s and how malicious, our statistical modeling thinks these files are. Now, the vast majority of these will be quite malicious because over 3 engines detected them as malicious. But let's take a look and see what it looks like. While that's running, who recognizes this? Anybody? That is the WannaCry kill switch domain. So if you want to find a bunch of samples of WannaCry, that's a great way to do it. Okay, this is probably done. Oh, all right. Well, something went wrong here. Let me, did this actually write out? But you can still see what it is.
It is the same thing.
I'm sorry?
Minimize this. You have this screen, and now you have the screen. And
You're breaking up a lot. I can't really understand what you're saying. Would it be possible?
The question, and maybe he can read it, Rahid.
Yes. Can you see if a certain hash has been scanned before? Yes. So I mentioned, and I showed on the web UI a few times, we searched various things that not everything was scanned yet. Like here's a good example. So what we're doing right now is we're kind of doing lazy scanning. So we're ingesting on the order of, we're bringing in about 300,000 samples a day, uniques. Not all of them are being scanned quite yet. We're working on improving the throughput of our scan process. When that throughput is improved, then we're going to be scanning everything as it comes in. But for the moment, if we want to have a lot of files in there, so you can find, you can metadata search them. The static extraction that goes into metadata search are always run on every file, whether or not they've been scanned. So you can still find these files, but actually getting scan results, for some of them, you're going to have to actually kick off a scan. That being said, once we improve this, we're overhauling some infrastructure on the back. We're actually going to run through our entire backlog of files that haven't been scanned. So in the future, this shouldn't even be a concern because everything will be scanned. But that's where we are right now. So if you want to see things that haven't been scanned, that's a good question. Let me have a query that would do that for you. One second. Oh, it's in a different repo. Yeah, so you could do something like, let me just try to come up with it. Exists, scan, not. Boom. Great question. If the scores are based on a statistical model, is it changing constantly? Yes. When you request a polyscore as part of the results, each time you request a polyscore, it will be different because the statistical models will be updated with the scans that the models have seen since you last requested. To give you a sense for how often we're scanning things, let's do. Yeah, so I just came up with this before I switch gears back to that. So anything that you put in this metadata query field, it just has to be valid according to Elasticsearch's Boolean search criteria. So we can do not, then we can do this special property underscore exists underscore. Then I'm looking for the scan object as part of the results. So that's going to list everything that hasn't been scanned. Whereas if I take away not, these have all been scanned, right? Not all of them are malicious, but they've all been scanned. Okay, so let me show you this real quick. So what I'm asking for is give me all the artifacts that were uploaded in a 5-minute time window, and they have they were detected as malicious by at least one engine. Yeah, that's what I'm asking for. Let's do. No, I screwed that up. This. And redirect that to temp. $499. So that kind of gives you a little bit of a sense. So even though we're not scanning everything that's coming through, in a span of 5 minutes on the 15th, we scanned 499 files, and at least one engine identified them as malicious. So we scanned far more than that. But those, that's the number that were deemed to be malicious. Okay. Well, I've kind of I've reached the end of what I was going to show in terms of hunting. I hope some people are interested in trying this out. I know I think it's pretty fun. Again, you can download these files. You can publish results from what you find on here. We really have no restrictions in terms of what you do with these files. So obviously we'd love to have some sort of link back or say like, hey, I got this file from Polyswarm or something like that. But yeah, we don't have any kind of restrictions like that. So if we get some people interested out of this conversation in hunting on Polyswarm and uploading more files, then we can improve this whole ecosystem together. Okay, I think I got a question. Can you say something about the Telegram bots? Yeah, so we have a Telegram bot, and it's in our Telegram channel, and it will automatically scan. It's not just in our Telegram channel. It's actually in over 300 Telegram channels at this point. And it will scan files that are posted to the Telegram channel by submitting them to Polyswarm. And will return results, in a text form. This bot talks back to the Telegram channel. We're developing Slack bots as well. We're not quite there yet. We have a private one, but we haven't released it yet. We're looking at Twitter bots. So one thing that we're interested in doing is, part of my daily job and some other people at Polyswarm is follow people that are active on Twitter and see what they're saying about different, new threats and things like that. Sometimes I post IOCs and then we'll take a look and see what we have and where we can improve. Our bot's going to be on Twitter and offer free downloads to people as a response to a lot of those posts because, unless you pay a lot of money to the likes of RSole, you can't download files, right? So yeah, another thing that we did recently on that front is we've partnered with VX Underground. And they are sending us many, many files, and in exchange, we're hosting their files for them for free. So we're engaging with the community on that side as well. We haven't started ingesting their files; they're not searchable yet. Yeah, thank you. Somebody just linked to more information at the Telegram bot. Yeah, is there a concept of reputation in Polyswarm? Great question. So there is a concept of reputation. It's not anything that's exposed. verbatim to users. We've kind of gone back and forth on that. What we've landed on is this statistical model that weights output of different engines based on file type and past performance, but not exposing that verbatim, that statistical model to users. The reason for that is a lot of engine developers, particularly upstarts, people that want to get their feet wet, try to detect malware, they don't necessarily want to be compared or have it be real easy to compare them against what is essentially their competitors. So, we're building the statistical model to distill down to the best sort of result that we can provide, single result that we can provide, but we're not in the business of helping people do sort of an A/B comparatives sort of thing. So we're not exposing that directly. So the other aspect that I'll speak on is, okay, cool. The other aspect that I'll speak on is, so everything that I've discussed so far today is in what is called our public community. And that public community is open to anybody. Like I said, you can store files on it. We store them on S3. So the public community, and actually when you click download, what you're downloading is a signed S3 link that's valid for a certain amount of time. So yeah, so what we're doing is everything that I've mentioned so far is in the public community, meaning anybody can build an engine, plug in, and start detecting things. And also what that means, conversely, is anybody who's technically capable of building an engine can get access to the feed of files coming in. So, for customers of ours that have files they need to be scanned that have potentially confidential information in them, obviously it doesn't work for those. So for paying customers, we set up what are called private communities that only have their chosen engines as a part of that private community. So anybody can plug into the public community, make a name for themselves, build up a reputation, at least in our eyes. We can introduce those engines to these customers and see whether or not the customers want them as part of their private community for scanning the subset of files that they have that are potentially malicious, if that makes sense. And there's higher payouts in the private community as well. So. Okay. Nice. Yes. Okay, back to this. Let's go back to presents. Okay, we just went hunting. So here we are. I did a bit of a metadata search deep dive. I can send along some links. One thing actually before I forget, if you go to github.com, I believe this is public now, /polyswarm /polyexamples. Bummer, it's not. Do I have that right? Okay, well, that will be public very soon. My apologies. There are a lot of docs at docs.polyswarm.io. And that covers a lot of heavy use cases of metadata searching, but we're publishing a lot more data on that front coming very soon. So a lot of things I demoed today, that's going to be in there. Let's go back. And, I kind of want to bookend this conversation with, again, encouraging anybody that finds what we chatted about today to go to go.polyswarm.io/polyx, engage with other people like yourself. There's a lot of sample sharing, there's a lot of threat intelligence, there's a lot of chat going on in there, and it would be great to have you all as well. So with that, I've gone on for about an hour and 25 minutes. I'd like to thank everybody and open it up for any kind of questions.
Thank you, Paul. Thank you for the great presentation. Hopefully, you will get a lot of excited and collaborating researchers. There's a question there.
Yeah, thank you. And again, thank you for having me. And one last thing, I did forget to go over one thing. This is a thing that is not free, which is why I didn't go over it. But for paid accounts, if you work at a company or something that would be interested in buying a paid account, you can search for things using YAR rules, right? So here's an example. YAR rule detecting Emotet. You can actually run these YAR rules against our entire hundreds of millions of files and get results. So that's very costly for us to do. So it's only available on paid plans, but I wanted to mention that as well. So anyway.
Any other questions? There's one here. Do you support threat hunting based on network indicators?
Great question. So yes and no. So network indicators, some of the demos I went over today, obviously we were taking a look at C2 addresses, we were taking a look at domains, but one of the limitations to what we're doing, but one of the limitations to what we're doing is these were C2 addresses.
Do you want any lunch? Do you want any lunch?
Somebody unmuted accidentally. Can we get a mute going on here? Somebody unmuted.
That sounds like more racers are coming up from behind, and they're coming up fast. Hurry, everyone! They're at the finish line.
Okay, it looks like it's Bia.
I got it.
Got it. Cool.
Come up again. There you go.
There you go.
Like whack-a-mole. Sounds like a fun show in the background though. Yeah, so, but one thing that you may have noticed as part of that is, these are statically extracted C2 domains and IP addresses. If it was something that was dynamically computed by the sample, that's not something that's going to be extracted today, and it's not going to be something that is searchable via metadata searching. That being said, the way to address that is really via full sandbox integration. And I had mentioned way back at the beginning that we have triage acting as an arbiter on Polyswarm, but the output of triage and a few other sandbox, we actually have several unannounced sandboxes. The output of those are not actually being made available yet. It's on our roadmap. We're hoping to get to it. We have a lot of things that we're building right now, but we want to get to that probably sometime in Q3 of this year. So when we have execution traces, when we have the output of, like, say, what files are written to, what registry keys are edited on Windows, and what network domains are reached out to, those will be metadata searchable the same way as everything else, based on those dynamic executions. But again, right now, it's limited to what can be statically extracted from the files, unfortunately. So, great question.
All right. So if there's no more questions,
Good catch. Somebody said I probably meant polyswarm.network, not polywarm. I don't know what polywarm.network is. Don't go there. Yes, polyswarm. This should be polyswarm.network. My bad.
gotcha. All right. So before we leave, just want to share this. We do have some very exciting content and meetings coming up. We have the OWASP Top 10 for API. Will be our next meeting on April 25th. Then we're gonna have Sandsbone's COBOL CTF. As some of you may have heard, they had issues in the state of New Jersey. Mostly, I believe, was the unemployment side because it was coded in COBOL. I'm not sure if you guys heard about it, or some of you are too young to remember Y2K, but should be exciting to look at COBOL and play a game with it. And then on Saturday, May 9, we're gonna have the Pwnagotchi. Pwnagotchi is specifically the Pwnagotchi is very proper for some of us that are in high intensive Wi-Fi environments. So we have some cool stuff lined up, and we'll be publishing this meeting soon in YouTube, and hopefully we'll have a copy as well of the the extra slides. So I'll thank you all for coming, and we'll be in touch. You stay in touch in Slack. I added some of you. Again, if you email me at info@bhack.org, I'll add you, and I will stay in touch. Thank you.
Thanks, everybody. Thanks for listening. Hope you have fun with Polisform, and hope to see some people in PolyX as well.
Thank you, Paul. Thank you, everybody. So this concludes our meeting. Again, thank you for making it out, and share the word. Okay.
Listen.
Keep safe.